Okay, so here we go with chapter 2, lesson 1. Okay, first thing we want to look at here is our first vocab word, so important vocab word here, an integer. So integers are whole numbers and their opposites. We're looking at positive whole numbers, negative whole numbers, and zero. So no fractions, no decimals, but we can have positives and negatives now. In our first examples here, we want to write an integer for each situation, then identify its opposite and describe what it means. So our first example, 23 degrees Fahrenheit below zero. Our integer that represents this situation, below zero means we're going to have a negative, so negative 23. Our opposite of negative 23, if it was negative, so now it's going to be positive, so just 23. And our description of this 23 for this situation would be 23 degrees Fahrenheit above zero. All right, moving right along. 11 inches more than normal. More is our keyword there. More is positive, so our integer would be 11. Opposite of 11 would be negative 11. And our description, 11 inches less than normal. All right, 1A down here, a loss of 8 yards. Loss denotes a negative, so negative 8. Opposite's positive 8. And a gain of 8 yards. And last up, a deposit of $15. Deposit is when you put money into the bank, so you're gaining $15. Opposite would be negative 15. And the description would be to withdraw $15. Okay, so there's a little bit of practice with integers. Our next vocab, moving right along, now we've worked with integers. Any mathematical sentence containing less than or greater than is called an inequality. So an inequality compares numbers or quantities. When two numbers are graphed on a number line, the number to the left is always less than the number to the right. We want to use the integers graphed on the number line below. For part A, we want to write two inequalities involving 1 and negative 2. So 1 is to the right of negative 2. So if I start with the 1, 1 is greater than negative 2. Now if I start with my negative 2 is to the left of 1, so negative 2 is less than 1. These two are both saying the same thing. 1 is greater than negative 2, or negative 2 is less than 1. In example B, replace our circle here with less than, greater than, or equal. So negative 6 and negative 4 and negative 6, how do they compare? Well, negative 4 is here, negative 6 is here, negative 4 is to the right of negative 6, so negative 4 is greater than negative 6. 2A, write two inequalities involving negative 7 and negative 3. Well, negative 7 is right here, negative 3 is over here, so if we start with negative 7 is to the left of negative 3, so it is less than negative 3. And if we flip it, negative 3 to the right, so it is greater than negative 7. And part 2B, replace the circle with less than, greater than, or equal. Negative 1 and positive 2. Any positive will always be greater than a negative, or any negative is always greater than less than a positive. So negative 1 is less than 2. Now notice with our numbers, when we're talking about positives, the larger the number gets, we're talking about greater than. For our negatives, as we move to the left, these numbers appear to be getting larger, but they are actually smaller because they are further to the left of our 0. All right, our next key concept here, we have a couple of them in this first lesson. The absolute value of a number is the distance the number is from 0 on the number line. The absolute value of a number is always greater than or equal to 0. So if we check out this example, we see absolute value of 6 an absolute value of negative 6. If we go to our number line, we have a negative 6 here, we have 6 here. We want to count how many units are they away from 0. So 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So the absolute value of 6 and negative 6 are both 6. They are both 6 units from 0. So down here, notice on the number line that negative 6 and 6 are each 6 units from 0, even though they are on opposite sides of 0. The absolute value of a number is the distance the number is from 0 on a number line. So they both have the same absolute value. Distance is always positive. Distance is always positive. We want to evaluate each expression, so the absolute value of negative 4. If we think about a quick number line here, 0, negative 1, negative 2, negative 3, and negative 4. So how far is negative 4 from 0? We see 1, 2, 3, and 4. So the absolute value of negative 4 is 4. It is 4 units away from 0. Part B, the absolute value of negative 8 minus the absolute value of 5. Well, negative 8 is going to be 8 units away from 0. Minus 5 is 5 units away from 0. Notice our absolute value lines are now gone. 8 minus 5 gives us a final answer of 3. Now we want to work with some algebraic expressions here. Evaluate 6 plus the absolute value of x if x equals negative 2. So if we rewrite this, 6 plus the absolute value of x, show our substitution step. So 6 plus the absolute value of negative 2. 6 plus the absolute value of negative 2 is 2 because it is 2 units from 0. And 6 plus 2 gives us an 8. And last one on this slide, 9 minus 5 times the absolute value of z, if z equals 3. So 9 minus, just going to rewrite the problem real quick. Now we show our substitution. 9 minus 5 times the absolute value of 3. 9 minus 5, it changes to parentheses now. The absolute value of 3 is 3, so 9 times, or 5 times 3, however you want to show that multiplication. Now order of operations tells us we do multiplication before subtraction. So 9 minus 15. And 9 minus 15 is negative 6. If you're not sure about your negatives yet, we will be working on those in a later lesson. But right now, just know that 9 minus 15 is negative 6. Alright, a couple more quick examples for you guys. Evaluate each side, then determine which symbol, less than, greater than, or equal, makes the statement true. Write your symbol in the box. So in order to solve this problem, our final answer is going to be our symbol in the box. We have to evaluate both sides. So negative 16 times 2. Negative 16 times 2 gives us a negative 32. Then over on this side, negative 2 times 15. Remember, we want to show each step. Gives us a negative 30 over 3. Bring this down, negative 32. How does that compare to negative 30 divided by 3 gives us a negative 10. Well, if we think about our number line again, which one of these is closer to 0, since they're both negative? Negative 32 is further to the left if you were to count it out on your number line. So negative 32 is less than negative 10. Your final answer is the less than symbol. And last up, what is the value of AB minus the absolute value of C? If A equals 14, B equals negative 2, and C equals negative 8. So if we show our first step, then we show our substitution. A is 14. Remember, right next to each other means they're being multiplied. B is negative 2. That's a 2 there, guys. Minus the absolute value of negative 8. Okay, so we're going to take care of this absolute value first. So 14 times negative 2 minus the absolute value of negative 8. Again, negative 8 is 8 units from 0, so that's a positive 8. And next up, our multiplication. 14 times negative 2 gives us a negative 28 minus 8. And negative 28 minus 8 gives us a negative 36. And again, if you had any issues with signs and how to work with them, we will be working with them in some of our later lessons. Right now, make sure you have all your notes copied, and any questions I will answer tomorrow.